Welcome in our today's mathematics class. We are still looking at number and algebra, basically algebraic techniques. We have seen earlier on in our previous classes that we can be able to have pronumerals substituted with values. And these values, we are looking at them as those which are positive. We were also able to look at application of algebra in the real life situation. So generally, we realize that algebra is very important because it is used by mathematicians in various fields to find costs in sporting events and so on. So as we go on with the substitutions, we want to look at substitution, but this time we are going to involve negative numbers and mixed operation. Remember, when you talk of mixed operations, these are situations where we have all the operations involved, addition, subtraction, addition, and division, and so on. So it is very necessary that we are able to know how to carry out substitution when we have negative integers. Now, as we can see from an algebraic expression, we can have, for example, given that t is equals to 8. T is a pronumeral assigned the value of 8, and then we are to simply substitute and complete the equation 10 plus 4t. At this point, the expression we have is not actually giving us the answer until we substitute the t with 8, and then what we get is the total value that we require. So if that is the case, then we find that t here is positive. We are able to have the substitution like that, where here it means 4 multiplied by 8. Now, take note that we were substituting positive numbers. 8 is positive, so when you substitute, this one is the same as 8, 10 plus, we have 32, which gives us 52. That is when we have a positive number. But how do we handle a situation when we have the value of a pronumeral given as a negative? We saw in integers, while we are adding and subtracting integers, we were able to identify and multiply or simply divide integers with negative values. And when doing that, it is always easier for us to know that the rule of multiplication of integers with same signs, that is, if it's negative, our positive will always apply. So as we carry out the substitution, we should remember that we are saying that substitute into an expression by simply replacing pronumerals or letters with numbers. These numbers are the numbers that have been assigned to those pronumerals. For example, if A is equals to 3, that's the value of A, then we want to work out this. If A is equals to 3, then can you be able to evaluate this? 3 minus 7A. 3 minus 7A. Now, for this particular case, we have A as positive, so it will be easier because this will be 3 minus 7 multiplied by 3. This one will give us 7 minus, this is 7 minus 7 times 3, that is minus 21. And if that is the case, you'll find that what you get is negative 14. You'll get negative 14. Now, it was easier because what we have here is a positive. But now, let us introduce a negative sign and see how it will behave. In that case, given that A is equals to, negative 3, then find 3 minus 7A. Find 3 minus 7A. So if the value of A is negative 3, then we shall have A substituted in its place as negative 3. So this one will be rewritten as 3 minus 7. Inside the bracket, we have the value of A, which is minus 3. Now, this is the place where I'm saying the rule of integers when multiplying like integers with the same signs or symbols like negative, negative, both of them should give us a positive. So this one will mean that this is 3, negative 7 multiplied by negative 3 will give us positive 21. Therefore, it has been reduced to 3 plus 21, which will give us 24. So we are saying that we substitute into an expression by replacing pronumeral or simply the letters with the numbers. We have done that, and we have observed the rule of integers as we do the multiplication. Now, it is advisable, before I even note this point, we are going to refer to this. It is very much advisable that here we use brackets. It's advisable we use brackets. It's advisable we use brackets around negative. So we are saying use brackets around negative numbers to avoid confusion with other symbols. Looking at the example we have, it is now 3 minus 7a. Inside the bracket, we have brought in a bracket and wrote there negative 3. So that's what you are trying to say, that use the brackets to show these negative numbers so that we can avoid the confusion. And that is how we approach that. So let us look at questions and see how we shall apply various steps that we have seen through as we solve the problems. So in this problem, we are to evaluate the following expressions using A is equals to 3 and B is equals to -5 or -5. Part 1, it is 4, it is 2 plus 4A. Part 2, it is 7 minus 4B. And lastly, it is B divided by 5 minus A. So starting with the first part, the question is 2 minus 4A. We haven't substituted, so we bring in the substitution. The value of A, we find that but A is equals to 3. So we shall substitute the value of A so that we rewrite it to be 2 minus 4 into bracket 3. This 3 is positive, so we shall maintain it like that. This one becomes 2 minus simply 12, where 12 is minus 4 times 3 gives us minus 12. So when you work out that one, you'll get -10. If you work out that one there, you'll get -10. Why are we getting -10? Because this one here is a positive, and this one here is a positive multiplied by a negative. So 3 times -4 is -12. So -12 plus this. So we shall reduce it by 2 to be a -10. That's to correct what we have there is a minus. So I'm saying 2 minus 4A is simply 2 minus 4A. Substitute 3 where we have an A to have 2 minus 4 into bracket 3, so that this is 2 minus 10, we get minus 12, we get -10. Now, looking at the second one here, the second one reads 7 minus 4B. 7 minus 4B, but B is equals to what? B is equals to -5. We have to maintain that. The expression is here. What we are replacing is there. So we shall rewrite this expression as we substitute. This will be 7 minus 4B, and B is -5. So if you have -5, then it will mean that this one is a negative, this one is a negative. Two signs that are like or are the same will give us positive. So this will give us 7 plus 4 times 5, which is 20. Hence, we have our answer at 27. Why we are arriving at 27 is simply because when you have two negatives, it gives us a positive, and that is why we have the number 27. Now, looking at the last one, we have B divided by 5 minus A. We saw earlier on that B divided by another number is the same as writing it as a fraction, where we have the numerator as B and the denominator as 5, and then we minus A. This and this are simply the same. So, but A is equals to here 3, and B is equals to, B is where? B is here, -5. So we shall substitute the values of A and the values of B in our expression, so that we shall have B, and B is -5, divided by 5. So we are done with this part, minus A. A is 3. So when you work out this, -5 divided by 5 will give us -1, and then -3. When you minus that, -1, -3 further, just as we saw in the number line. When you are subtracting, we normally go to the left. So if we head here at -3, when we say -1, we shall move to the left. So this one will give us -4. So -1 -3 will give us the answer as -4. So we are saying that the expression we have at the end there can be simply substituted and reduced to -4. Now, it is very important that we substitute correctly, and that's why I want us to look at a question now where we have been given various substitutions. Are we able to identify and say this is the correct substitution? Let us see. So the question reads, which one of the following shows the correct substitution of A is equals to -2 into the expression A minus 5. So we have the expression A minus 5, and then we have the value of A given above as A is equals to -2. Now the question is, are you able to carry out the correct substitution so that we can identify out of these 4 options that we have been given, which one is the correct one? It is advisable here that we don't just rush for the multiple choices and pick, but we go and work out correctly and see which one is supposed to be our answer. So I'll not look at the answers we've been given, but I'll move ahead to our expression and the value of A and substitute correctly as we resolve it. So A minus 5 is equals to, that's A minus 5 is the same as, substitute the values of A. A is 2, so it will be -2 inside the bracket and then minus 5. When you simplify that, it is simply -2 minus 5. -2 minus 5. We know the answer should be -7, but let us see. Is there an expression out of these choices we have that has this value? So the first one here is 2 minus 5. It's not the case because of this first digit. The second one is -2 plus 5. And this is -2 minus 5. So this one again is put off because of that part. The third one is -2 minus 5, -2 minus 5. So we take up the third one to be correct, and definitely it means that the fourth is not correct. Why is it not correct? It's because this is -2 minus 5, this is 2 plus 5, which is 7. So we have our answer as this is the one that will give us the correct simplification of the expression. Now we have the question. Evaluate the following expressions using the values a is equals to -5 and b is equals to 3. The first expression is a plus b. Second one is 6b minus 7a, and the last one is 5b plus 2a. Now, we start from the first one by simply carrying out correct substitution directly. So when we have a plus 5, then a is -5, put it in bracket, and then plus b, and b is -3, put again in the bracket. So a is -5 and b is that. So we were working out, these are not like terms. When two terms are of the opposite signs, then it means a subtraction. So this one will be -5 minus -5 minus 3. So we are only supposed to do what? To evaluate. So -5 minus 3, what do you get? You find that -5 minus 3 is simply -8. We shall get our answer as -8. So having done part 1, the second part here, it requires us to evaluate 6b minus 7a, where b is -3 and a is -5. So rewriting this one, it will be 6 multiplied by b, but b is -3, close the bracket, and then this one will give us -7 into bracket a, and when we are given a is -5. So we start observing the rule of multiplying integers. 6 times -3 will give us -18. While -7 multiplied by -5 will give us positive, so we shall have plus 35. Positive 35, because in this particular case, a minus and a minus will always give us a positive. So having reached here, you can simply calculate your answer by simply taking 35 minus 38. 35 minus 18, sorry. 35 minus 18. When you subtract 35 minus 18, you will get your answer as positive 17. So here, we have seen that we can simply subtract and multiply. We can conclude by substituting, and then we multiply, and then we come and do the operation with a subtraction or addition, and we come and evaluate to get our answer. For the last bit, we have 5b plus 2a, and this one b is 3, plus 2 and 2a and a is 5. So that's what we have. We said we use the bracket when the numbers are negative. So this one will give us -15. This one will give us -2 times 5, and we have a -7. This gives us 10. Both of them are negative, so we shall receive the answer as 25 negative. We want to look at one more. This time, approaching it from a point of view where each expression has got independent values for their pronumerals. Evaluate these expressions for the values given. We have 18 divided by y minus x, and in bracket we are told x equals to minus 2 and y is equals to minus 3. X is equals to negative 2 and y is equals to negative 3. That is, we shall tackle it independently. So at every expression given, we have the values of the pronumerals. So what we are interested mostly is for you, the learner, to do what we call correct substitution. And for this case, we shall have 18 is a constant and a whole number. Divide by y is simply the same as over y, and then minus x. But y is negative 3. So this one is the same as 18 over y, and y is negative 3, minus x, and x is minus 2. The bracket here is very important. It shows us what are we going to do, what are we going to consider while multiplying to get rid of the brackets. There is a common factor between here. As much as the numerator is positive, the denominator is negative. The rule is simple. When you take a positive number, divide by a negative quotient, you'll always get a negative. So, before we even move further, we already know the answer here is negative, because this is a positive divided by a negative. So if that is the case here, the highest common factor by 3 here is 1. We have by 3 here is positive 6. This is negative 1. Now, having done here, we move to the second part. It is minus, in bracket, minus 2. Which means it is, we are going to multiply, so this assumed to be there is a 1 here, multiplied by minus 2. So, if that is the case, what have we remained having worked out this? What have we remained with? You'll notice that negative 3 gave us negative 1. So 6 over negative 1. A number divided by a negative is a negative. And a number divided by a number divided by 1 is a number. So 6 divided by 1 is 6. But 6 divided by negative 1, it is negative 6, because it is a positive and a negative. And then having gotten 6, then we move ahead and resolve what is here. Minus 2, it will simply mean a plus 2. So for that case here, we shall come and have 6 divided by minus 6, which is negative 6. And then we have, that is minus 6, and then this side we had minus 2, which is the same as plus 2. And when you add this, what you get is an 8. So the knowledge behind this is what? Is doing what we call the correct substitution. So we look at one last involving these various pronumerals. And this one, again, just the way we looked at it, we have to evaluate given the values of the pronumerals in the bracket. Evaluate minus 36. So we have the values. We are to evaluate minus 36 divided by a minus ab. This is ab. The values of a is 18, and the values of b here is negative 1. So what do we do here? Correct substitution is the rule to observe. This is a constant, we remain with minus 36. Divide by is the same as having it down here as a, then minus a, b. If you work out like this, substituting, where we have a, we put 18, so it will be minus 36 over 18 minus a, b. A is 18 and b is negative 1. That's very, very interesting. B is simply a positive. A is a positive and B is a negative. So already, before we open the bracket, there's something taking place inside the bracket, a positive and a negative. So the common factor between 36 and 18 is that is 18 by 18 is 1 by 18. Here is 2. So we have 2, the minus 2, sorry, over 1. So what we have is minus 2 over 1, then minus a. What we have here, 18 multiplied by negative 1. And when you multiply 18 by negative 1, you'll find that you'll get negative 18. Now, I want us to be very keen here what's happening. There is a negative here, and then there is another negative side here. It's like we are saying minus 18, then multiply by, so it's like saying minus 1, and then in bracket we had AB, where A is 18, multiplied by minus 1. So if you are very keen, you realize that here, they have created a bracket. We are bringing in AB, and AB shall place it inside the bracket. You should notice that minus is outside. So we have one negative inside and another negative outside. That's what we are trying to say here. So if we substitute 18 and negative 1 will give us negative 18 inside the bracket. And what is outside the bracket is negative 1. So negative 18 and negative 1, the product gives us a positive 18. So you realize that for this particular case here, the product will give us, this is a negative 18 and a negative 1, it will give us a positive 18. So we have 2 over 1 plus 18. We have 18 as it is. Now, it has changed to be positive. Why? Because a negative and a negative gives us a positive. That's why we have a positive. And minus 2 here over 1, we said 1 below there is insignificant, so we shall just remain with our answer as minus 2 plus 18. Minus 2 plus 18. And when you simplify further, you get this is the equivalent to 16. That is 18 minus 2. Now, similarly, just the way these ones are handled, the same algebraic expressions can still be approached in when we look at longer statement where we have a problem description, we formulate the unknown pronumerals, we move ahead and do the substitution, and we resolve to get our answer. I want us to look at this question. The formula for the perimeter So the formula for the perimeter P of a rectangle is given by P is equals to 2L plus 2B, where L and B are length and breadth respectively. Breadth. So what do we realize here? So the question says, use So we shall look at it step by step. The formula for the perimeter of a rectangle, P is equals to 2L plus 2B, where L and B are lengths and breadth respectively. Use the given formula to find the perimeter of the rectangle, given that L is equals to 3 and B is equals to 5. L is 3 and B is 5. So this case, it is simple. We simply take perimeter, because what we are looking for is equals to 2L plus 2B. This is what we are looking for. The value of L is here. The value of B is there. So we should be able to substitute and get the L we want to get here. So we find that this is the same as 2 in bracket L. And the value of L here, L is there. We are given L is here, L is 3, close the bracket, and 2 into B, and the value of B here is 5. B is 5. If B is 5, then it means that we can simply now move ahead and substitute 2 times 3. So you find that our P, perimeter, is equals to 2 times 3, which is 6, plus 2 times 5, which is 10. So this one, the perimeter is 16. The perimeter there is 16. So here we've only substituted, and you realize that all the substitution we are making here, they are all positive. But supposing part 2 of this particular question is saying L is 7 and B is negative 8. So we are changing the values of the polynomials, where we have given that L is equals to, we are looking at L, and given that L is 7 and B is negative 8. Now this is the major bone of contention, where we are interested on how you will treat this negative sign. And that's why before we started doing further mathematics, we introduced ourselves to the integers and operation of integers with negative signs. So rewriting the formula we have, I'll use the above here. The formula that we have is P is equals to 2L plus 2B. But L is 7, so it will be P is equals to 2 into 7 plus 2 into B. And B is negative 8, so I'll bring negative 8 here. So we are done with the first part of the substitution, but not done with the answer. So carry out the issue of removing the brackets accordingly. So finally the perimeter is equals to 2 times, everything is positive, so 2 times 7 is 14, and 2 times negative 8. 2 times negative, I did say negative 2, but 2 times negative 8. We have a positive and a negative, and a positive and a negative gives us a negative. So the sign here is going to change. We shall have minus 16. So when you subtract this, you'll find that the perimeter here is going to read negative. That is negative 2. Why negative 2? Because 16 is greater than, is a higher value than 14. Therefore, when you're subtracting, it will always affect our results, and that's why we have P simply as negative 2. So we have seen that we can still apply algebra in real life situation like what we have done in a triangle, in a rectangle, but put in mind that as long as the values of the polynomials change to negative, then we must be ready to observe the rules. Now, I want us to look at something else, something new, this time round about what we call the number patterns. It's a small piece that we can easily look at. We call it the number patterns. Now, the number patterns, this is a situation where we attempt to simply find the next number in either a sequence of or a series of terms. We are trying to find out what is going to be the next number. And for us to get that, we don't just assume that the value just comes, but there is a need to study the pattern that we have, and then we come up with a way of how do we get the next empty space with the next value of the terms. To do the number patterns here, which is also known as the sequence, we must be able to see that each number in a sequence must be looked at keenly. And the number we are saying that we are coming across the sequence. If you don't want to say a sequence, this is the same as what we are calling the number pattern. Now we are saying that for us to work out number patterns, which are also known as sequence, they have a number. Each one has a number, and each number, we call it a term. We call it a term. Now, if we have a pattern of numbers, like we all know, if somebody just starts writing down 1, 2, 3, 4, definitely if I'll ask you to tell me what is the next number, you'll tell me the next number is 5. And after 5, what will follow is 6, and then 7, and so on. This is a sequence or a number pattern on its own. We ask ourselves, what was happening for this person to get the next number? You'll get that the next number was being found by simply adding 1. And if you are adding 1 to the previous number, 1 plus 1 is 2. Then take 2 again, add 1, you get 3. Take 3, add 1. So we have already studied the pattern of the sequence, and we already know what we can do to get the next number. So we are supposed to study the terms and the pattern of a particular sequence correctly before concluding and saying the next number will be like this. For us to study and determine or to strategize to determine the pattern involved in a number, we need to look at a few steps. When we are strategizing to determine the pattern involved in a number of sequences, we must observe a few things. One, there's something we call we look for a common ratio if the common ratio exists in that pattern or it doesn't exist. If it exists, it will be easier for us to identify the next number. For example, looking at this, when we talk about the common ratio, you'll realize that it is either increasing or it is decreasing with a constant amount. When we have a common ratio, there is a constant amount of either increasing or decreasing. For example, if we have 2, 6, 10, we have 2, 6, 10, 14, right? The next number would be what? So let us see. What will be the next number? From 2 to 6, we added 4. Add 4 to 6, 10. Add 4 to 6, 14. So we expect the next number to be 18 and the next one to be 22. What is happening here? You'll find that for us to obtain the next term, it is increasing the previous term by 4. So we can simply say here, there is actually a term, every next term is increasing by the value of 4. So this one here is what I'm calling the common difference. For us to get our common difference here, let us look at this. Is not a common ratio, but it is the common difference. So the common difference here, every time we get the next, there is a constant increase of value. And the constant increase here is 4. So 4 is what we call the common difference. How do we obtain 4? It is the next term minus the previous term. For example, 6 minus 2 is 4. Take 10 minus 6 is 4. Take 14 minus 10 is 4. 4 is constant. 4 is the one which is making the pattern here. So 4 is what we call the common difference. To get the next pattern here, we shall keep on adding 4, 4, 4. That is the common difference. There is what we call the common ratio. Again, it is important as we continue looking at studying the pattern, we must identify what we call the common ratio. Now, in this case, each term is being multiplied or is being divided by a constant. This is simply, a common ratio is simply acquired when each term is being multiplied or divided by we are multiplying or dividing by a constant term. So if that is or a constant amount, if that is the case we are seeing, then what could be the example of a common ratio? Study the following pattern. This is a series of numbers. We have 4, we have 2, we have 4, we have 8, then 16, then 32. So before we decide what is the next number, we need to study the pattern, the previous pattern of this sequence. What happened to 2 for us to get 4? You realize that there are two ways. Either we square to get 4, or we multiply by 2 to get 4. So we have got two options, either squaring the previous or multiplying by 2. So if that is the case here, we get 4. Let us look at the fourth, the second one, between the second one and the third term. What happened? 4 to get 8. Let us square 4. If we square 4, it is 16. So we are putting off the issue of squaring a term. If you take 4 multiplied by 2, do we get 8? Yes, we get 8. 8 multiplied by 2, 36. 8 multiplied by 2 is 16, and 16 multiplied by 2 is 32. So when you are multiplying by 2, you find that the number 2 is constant. And when that number that we are calling constant is multiplied by the previous term, it should give us the next term. That 2 is what we call the common ratio. So the next term here is 32 multiplied by 2, which is 64. Or if you are to get it going backwards, you would take 64 divided by 2, 32. Divide by 2, 16, divided by 2 as you move on, like that. This is the common ratio. There is also need to look for increasing or decreasing. There is need to look for increasing or decreasing difference, increasing or decreasing difference. Now here, if there is a pattern in this situation, we want to look at a pattern, for example, 1, 3, 6, 10, and 15. Now, here, we need to look at the pattern, whether it is increasing or decreasing, but what is there a pattern there? And if there is a pattern, what is happening here? I want you to look at we are talking about either increasing or decreasing difference. Now, the difference between 1 and 3 is 2. The difference between 3 and 6 is what? Is 3. The difference between 6 and 10 is 4. The difference between 10 and 15 is 5. So you realize that we are experiencing increasing difference. That is 2, we added 4, we added 2, then we added 3, we added 4, and then we added 5. It keeps on increasing. That is how this pattern is found. So if somebody asked you for the next one here, definitely here you'll have a 6. So if you add 6 to 15, that one will give us the next term, which is 21. So this is what we call increasing difference. It could be also a reducing difference. All of them will fall under the category of increasing or decreasing difference. Next part, next one is when we look for two interlinked patterns. Looking for what we call two interlinked pattern. We have an example like 2, 8, 4, we have a situation where we have two interlinked patterns. Now here, it's a bit tricky because when you look at this, there's a bit of issues that we need to look at. What is happening here? Is it anything to do with the odd? So here, we have the pattern in the odd numbered terms and another pattern in the even numbered terms. We have even and we have odd. If you are very keen here, 8, 4, and 6 are both even, and then we have also 2, 8, 4, and 6 are both, all of them are even, and then we have 7 as our odd number. Now, what happens here, we want to look at the odd number that we have, and this odd number, we are going to increase it, and having increased it, we see whether we shall develop a pattern from this, because it's a matter of we want two interlinked pattern. So it's not just single one, but there are quite a number of patterns that are involved. Now, the odd number, if we know the odd numbers that we have, odd numbers are like those numbers which are not divisible by 2, like for example, 3, we have 5, that is a pattern of odd numbers. 3, we have 5, 7, and so on. Now, those are simply odd numbers. And even are those ones which are divisible by 2 or ends with that 2 or with a number divisible by 2 or simply 0. Now, we want to look at a situation here where we want to increase odd numbers by 2 and even numbers by 1 and see what are we going to get. Even numbers, we are going to decrease it by 1, and odd numbers, we are going to increase it by 2. Now, when we look at this, between this and that, this other one, we have got even number, and we are saying that for the even number, we increase the even number by, we decrease the even number by 1, and we increase the odd number by 2. So, if that is the case, the odd number here after 2 is 3. If we increase 3 by 2, we shall get a 5. And if we reduce an even number here by 1, we shall get a 1. So you find that 5 and 1, we have got 5. 1, we have reduced even by 1. That is, we have 1. And then we have increased, odd number here is 3. So we increase 3 by 2, we get 5. Then 5 plus 1 is 6. So if you take 6 plus 2, you'll get 8 here. So this situation here is what is bringing what you are calling interlinked. And interlinked here, we need to note it clearly. We have clearly the odd number here. We add, or sorry, we increase odd number by 2. We should indicate that clearly. Increase by 2 and decrease even number by 1. Now, when the situation here is that the odd number we have here is a 3, and the even number we have here is a 2. When we reduce a 2, we get a 1. When we increase a 3, we get a 5. 3 and 5 summed together gives us a 6. A 6 added into 2, you'll find that we are going to get an 8. Now, when we move ahead, we are supposed to go on reducing and also adding, because the first odd number was 3. The next odd number is supposed to be a 5. And the next even number that we have is supposed to be, the next even number we have is supposed to be a 4. So we are going to reduce a 4 by 1, and then we take a 5, we increase it by a 2. So if you increase 5 by 2, you'll get a 7. If you increase 5 by 2, you'll get a 7. And if you reduce what you have the next even, which is 4, if we go and reduce it, you'll find that we are reducing by 1, it will be a 7 and a 4. So the pattern that is here is different because they are two linked. We have the even 4 has been reduced by 1 to be 3, and the odd number 5 has been increased by 2 to give us a 7. So a 7 and a 3, the relationship here to give us 4, they have taken a subtraction. This was addition. The second part is simply a subtraction. And you find that when you have 7 minus 3, you'll get your 4. Now, what you'll realize that in this kind of sequence, that is, we have two interlinked patterns, there is that need that a learner requires to study and understand very carefully what exactly is happening. So I want to take it from here that in our next class, we shall start from the interlinked pattern and see how can we actually insert interchanging, relating the odd numbers and the even numbers, and develop a pattern so easily when we have two interlinked patterns. As we look into that, I want you to go and review your knowledge on the odd numbers and even numbers. Get clear, have a list of odd numbers and a list of even numbers, and from there now we come and get to this pattern and see, are we able to study a pattern from this so that we are able to add where we are supposed to add and reduce where we are supposed to reduce, and then look at the relationship. Can they develop something that is a pattern? So let us stop from there. In our next class, we shall continue in a number of patterns and see many other patterns, how they can be developed. Thank you.